Welcome to the ftir.fun Infrared Learning Series. This episode of 23 Polymer Industry, Plastic Identification and Blend Analysis. Then close with a checklist. Next, i.e., the fate of a truckload of unknown plastics in March 2024, a recycling plant in Zhejiang received a truckload of imported engineering plastic scraps that the seller claimed to be PCABS alloy at a price of 18 Chinese yuan ton. However, after granulation and injection molding, the samples were brittle and had a hazy surface, completely inconsistent with the expected performance of PCABS. The factory lab scanned it with a tryst. The spectrum indeed showed characteristic peaks of PC polycarbonate at 1,770 centimeters and 1,230 centimeters. Of the characteristic but hadini double bonds 965 centimeters of apps were barely visible. Instead, distinct styrene homide polymer peaks appeared at 760 cm. This was actually a cheap counterfeit of PC blended with HIPS, high-impact polystyrene. Next, ftir is the golden tool for plastic identification. 1.13 Major scenarios for plastic identification. 1.2 Survey as other plastic identification methods. Next, IN. Practical advantages of ATRE for rapid plastic testing. 3.1 Why is ATRE the first choice for plastic analysis? Plastics are typical solid samples, and most are insoluble in common solvents. Conventional transmission methods pose difficulties. Pre-pellet plastics are hard to grind, and heating may alter structure. Film method requires hot pressing or solvent casting. Destructive liquid cell plastics are insoluble and cannot be used. Next, strategies for differentiating blends and copolymers. 4.1 Blends vs copolymers. Can ftir differentiate? Problem: PCABS alloy blend and PCGABS graft copolymer have nearly identical ftir spectra. How to distinguish? Next, infrared characteristics of fillers. 5.1 Infrared fingerprints of common fillers. Plastic modification often involves adding inorganic fillers to enhance performance. These fillers have characteristic absorptions in the emitting flared region of 4,400 centimeters eye contact. Next, practical case identifying an unknown plastic fragment. A hard plastic fragment of approximately 3 times 3 centimeters was received. Semi-translucent milky white from a failed part complained by a customer. The request was to identify the material and determine if it is the specified grade PCABS. 6.2 Identification process. Next, infrared sorting in plastics recycling. 7.1 On-mine near-infrared sorting. Near sorting. Larger-scale recycling sorting lines commonly use online near automatic classification. Next, industry experience and pitfall records. 8.1 Pitfall 1 Surface contamination leading to misidentification. Case P in a plastic part had oil on the surface. Letter showed a strong peak at 1,740 centimeters, misidentified as containing polyester. After cleaning the surface and remeasuring, 1,740 centimeters peak disappeared. It was mold release agent, stearate ester residue. Next, we received an opaque white hard plastic. Vector spectrum shows peaks at 1,774, 1,230, 830, 757 centimeters. 2,237 centimeters is absent. An injection molded part contains 30% glass fiber and 70% PA66. The ATRE spectrum shows a strong broad peak at 1,050 centimeters, double peaks at 1,635, 1,540 cm. Finally, the drill actualists. Make sure you can recall each item. Key ouch points. Key points. Plastic ftir identification. ABRES preferred. No sample prep. Non-destructive. Best. Quick reference for 9 major plastics. P720 PP1, 1376, 841st, PS 700 757, PVC 690 615 at 1714. 1635 1540 PC 1774. Helmo 1730 EPS 2237. Advantages of a tray. Surface analysis. Fast. No sample pre. Good reproducibility. Blend identification. Characteristic peak addition. Relative peak intensity ratio. Quantification. Difference spectroscopy. Blend vs. Polymer. Kerr cannot easily distinguish. Need DSC. Number of TG or extraction separation. Common fillers. Glass fiber 1050C Cozy 175 712. Talc 673,677. Steel 1100. Identifying filler interference. Strong peaks in polymers and opaque regions are mostly fillers. Neck plastics. Ear fills. Need ultra XRF. Density methods as aids. Identification. Go app. Observe physical properties at your measurement library search. Manual interpretation combined with DSC-TGA. Common pitfalls. Surface contamination. Filler misidentification. Single library search. Ignoring aging. That covers the required sample for this episode. Practice with real spectra on ftir.fun. And continue with the next lesson.